out of Australia by a company there that does emergency lighting called Nexus. And based on today's NFPA, so the National Fire Protection Association, all the codes that are written around fire protection, in the lighting portion of it, they talk about emergency lighting and what needs to be done to maintain your emergency lighting. They also have requirements with regards to foot candles and stuff. We're not going to focus there. But kind of a semi-unknown fact for a lot of people, but not so much for people in industrial facilities and commercial facilities where they have a life safety person on staff, that's their primary role, is to make sure somebody's not getting injured or killed on the job. There are specific requirements for testing and maintaining your emergency lighting. The way the NFPA is written is once a month, you're supposed to go around and physically test or physically observe it if it's a self-diagnostic, and then physically document every exit light and emergency light worked when tested. So with a non-self-diagnostic, you have to physically go push the button. So like that guy over there, you have to push the button for 30 seconds and verify that it worked properly, and then document that once a month. Once a year, you're supposed to shut the power off to all of your emergency lighting to put it in a physical load test for 90 minutes, and then physically document that all that's taking place. Most engineers do not circuit buildings to where you can shut off just the emergency lighting. So invariably you're shutting off other stuff too, which then means if you're gonna do it, you have to do it during after hours, change of shifts, those types of scenarios, so that you don't obstruct production or make it a dangerous environment, because you're gonna turn off all kinds of stuff. There's one last category though that they talk about in the NFPA, and it's this number one here in section sub 23. Or you can have a computerized self-testing system that documents and actually puts the product into physical test form and then documents it in centralized fashion. So a computer-based technology essentially. What Nexus came out with, they had a wired version at first, then they had a wireless version, just an RF frequency version that still had to reside on a network somehow. And then a couple years ago, they came out with their cloud-based version, like almost all companies are doing now, having something on the cloud. What this system comprises of, if we work it backwards from the end user, so if I've got my Droid or my iPhone or a wireless tablet or even just a laptop, I'm connecting through the cloud, ABB's cloud, to the local router at the facility. It's just a simple router like you would use for anything else that you would connect wireless equipment in a building on. It doesn't have to reside on their network. Okay, so it can be totally separate from an entity's network, therefore no security issues. That then communicates to a gateway, so this is physically plugged into the gateway. This is wirelessly now connected to the router, the gateway. The gateway is where the brains of the system are stored. Temporary information from the cloud is stored on here, as to the individual devices throughout the facility. It's a mesh network, just like you're seeing a lot of other technologies. If I had these four fixtures, they're all communicating with each other as well as to the gateway. So if one fails, it bounces away from this one, goes to the next one, and it's a self-healing mesh network to communicate. With the Nexus system, the Nexus Pro, you're able to do up to 200 devices, and devices being emergency lights, exit lights, combo lights, and we even have now mini inverters that can be on this system. The way the mini inverters work is really cool. When you power, you bring your lighting equipment to the mini inverter and connect your load. When it fires up, it recognizes what that connected load of those fixtures are on the system. When it goes into emergency mode, it'll only detect a load variance to determine if one of the fixtures is not working. Can't tell you which fixture is not working, but it can tell you that, hey, there's a fixture not working, you need to go take a look at it, okay? So the way the system works, as I mentioned, is you've got your gateway, and then they're all wirelessly communicating throughout the entire building. What this system does, this is an example of kind of a small application, and then this is an example of a larger one where you would have a gateway at each building, but they can all be connected together on the cloud so that you can view them globally. So if you have a campus environment like we're doing UT right now up in Austin, you can do multiple buildings and they can all be viewed in a global capacity, or you can drill down to each individual building and so forth. So here's kind of how it would look in a screenshot view with a globally viewed system and then each location. It gives you an instant view of the system's health as well as a testing schedule, and everything's done on a push notification basis, so it's constantly communicating. So here's what's happening. You fire up this network and all of your exit lights and emergency lights, we'll just focus on those for right now. The system is constantly diagnosing the product that they're online and functioning properly. The battery, the LED boards, individual lights on the a combo, any of the communication equipment as well as the physical illumination equipment and batteries are being tested and monitored. If one fails, you'll get almost an instant notification that the battery and the emergency light in hallway 101 at the end, however you designate it on there, the battery has failed. It tells you the part number of the battery that you need to replace. The minute you put that battery back in, the system's constantly checking, it's gonna heal itself, say, yep, it's back, working great. The reason that's important is you can get a snapshot at any time that all of your emergency lighting is functioning properly if a fire marshal comes to visit. The other thing this system will do, remember I mentioned earlier on about the once a month testing and once a year full discharge. You can program into the system to where it will perform those physical tests. It'll send the fixture into bypass mode as if it had lost power. And it'll test the fixture once a month for 30 seconds and then once a year for 90 minutes. And what's really cool about this is you can schedule it for 2 a.m. in the morning, and you can also schedule it, say you've got that hallway again has 3 emergency lights. I can do one on one night, one the next night, one the next night. There's nothing in the code that says they all have to be done at the same time. They just have to be done once a month and once a year. So you can schedule around shifts. You can make it to where nobody's physically present most likely, or if there is somebody present, you're not shutting off all the emergency lighting in an area, you're just doing little portions of it for those brief test periods. The reason that's important is you have that testing documentation now, so again, if a fire marshal comes and says they want an inspection, all they gotta do is print out the report, say we're good. You can go around and test them if you want, but per the code, we're covered. So another cool features that have come out, you can either look at it as a device list with their physical locations in the building, however you want to designate them, or you can import a floor plan, CAD, and you can have them designated on the physical floor plan. And it'll show up as red if it's not functioning or a green check mark if it is functioning. That's what we're going to be doing on this recent project. They have complete CAD drawings of all their offices, production areas, and so forth. Not only are we going to be able to, what we're doing is we're physically locating where all their existing emergency lighting is. We're going to suggest where they need to add emergency lights where they're deficient and be able to put those on there. They'll be able to overlay on their drawing and they'll have a more complete layout of their emergency lighting for their facility. Gives you all the details down to an individual device. So if I opened up a particular exit light, I can see everything that's going on with that exit light as well as its history, and also the detail of the test results throughout its history. So you can do it, by room, you can do it by device, you can do it by the entire building, however they want to look at it. Now this is where this is really interesting. With everybody's on retrofit to save money, right? Cut your energy costs, help pay for the system. Exit lights don't consume a lot of energy. Emergency lights certainly don't, because normally they're not on. So there's really no energy savings analysis. The return on investment, and this is the only emergency lighting system in the market that offers this, is on the labor side of it. So let's go back to that life safety person in an industrial facility or commercial facility. Typically the life safety person only answers to the general manager of the facility. They are in direct contact with them. There's not usually tiers of people in between a life safety person and the general manager. So they've got the general manager's ear. A life safety person in a high potential injury facility with heavy machinery and so forth, they can shut the plant down. I mean, they can override the general manager worst case scenario and say, this is unsafe, we have to stop now. So they swing a lot of stick, a lot of stick. One of the items on their checklist is keeping up on emergency lighting. So usually they're going to deploy somebody, a maintenance person, that's going to go out and do the testing and do the maintenance and so forth. Every industrial and commercial facility has an internal labor rate that they assess when they evaluate cost of doing business. It's a fully burdened labor rate. So it's not just the person's salary, it's going to be what do they cost us insurance, what do they cost us taxes, fully burdened labor rate. So it's very easy to say, and sorry, it's kind of squinting here, it's very easy to say $70 an hour is a reasonable, fully burdened internal labor rate, even in the South. Get outside of the South and it's way higher. If I were to take a system that's got 20 exits, 15 battery units, and 10 combos, so a total of 45, which 45 to 50 total units is kind of the sweet spot for this. If you're looking at a facility that only has like 10, and that's their only building, it's gonna be hard to show an ROI. Get to 45 to 50 units. We do a comparison here where we're showing a standard exit light system, advanced diagnostics. You still have to physically document that the fixtures are working, and most people don't even know what the different Christmas tree of lights means, so they have to look up and see, oh, is this function, is it, which light's which. And a Nexus system. When you compare the cost and the monthly testing versus and the annual testing for their maintenance per year, this system will show a 15-month payback. Very easy to document. It's very quantifiable. These are tests you're supposed to perform. It's not, there's no ambiguousness about it. It's not how many hours am I burning the lights versus different shifts and stuff. So you're not having to make really any assumptions here. Even on a large system, where I'm doing say 60 exit lights, 45 battery units, and 30 combos, I still come in 16 and 15 month ROIs every time. So you actually can present this from a return on investment. You kind of go in with a scare tactic at first. Are you keeping up the emergency lighting? If somebody gets injured, it's first thing lawyers are going to look for to sue and all that kind of stuff to get them on the hook. Always have a life safety person involved in the discussion at the onset if you can, because this directly ties to them. Maintenance person, they'll see a benefit to it, but they're not going to really buy in nearly as much as that life safety person is. And you're also taking a maintenance person away from going around and pushing buttons on lights and having them work on way higher and better use projects for the facility, something more attuned to the value of their time.